This is section 6.4. We're going to prove triangles similar by side-side-side similarity and side angle side similarity. So we're going to learn two new shortcuts in this section. In this video, we're going to focus on just this one. Now, before we even show the theorem, you should know what this means. If we're talking about similarity, and this is a shortcut for showing that triangles are similar, then you're going to need three pairs of proportional sides. And if you have those, then your triangles are going to be similar. So that's exactly what this side-side-side similarity theorem says. If the corresponding side lengths of two triangles are proportional, then the triangles are similar. So for example, if this segment divided by this segment is the same ratio as this segment divided by this segment, and this segment divided by this segment, then the triangles are similar. You don't need to check the angles. So this is a really, really powerful theorem, and we're going to show where you can use it right now. Is either triangle DEF or triangle GHJ similar to triangle ABC? So here's triangle ABC. I'm going to see if this triangle is similar to this one first. So what I'm going to do is I'm going to write down my side lengths for this triangle, and I'll put them in order. 8, 12, 16. Now I'm going to do the same thing over here with this smaller triangle. I'm going to put the sides in order as well, because if they're similar, then the sides have to go in order: small to small, medium to medium, big to big, so on and so forth. So we're going to do 8 to 6, 12 to 9, 16 to 12. Are all of those ratios the same? Well, let's think about it for a second. I don't really have a calculator to display for you, so I know that 2 goes into both of these. So this would be the same thing as 4/3. I know that 3 goes into both of these. So it also would be 4/3. And I know that 4 goes into both of these. Since all of these are equal, these two triangles are similar. Now, we'll do this example over here to show you why they're not similar. We're going to do the same thing. We're going to put an 8, a 12, and a 16 in order, and then match these up. 8, 10, 16. Now, clearly those aren't similar. I think you can see that these are a 1-to-1 ratio, but these ones aren't. These ones equal each other, but these two don't equal that guy. So it's this guy. Use the side-side-side similarity theorem. This one's about algebra. Find the value of x that makes the two triangles similar. Triangle ABC similar to triangle DEF. So is this little triangle similar to this big triangle? It's natural to say, well, I think this goes with this. And you're probably right. But what if this was not a translation of that? Use your statement. Segment AB has a length of 4. What does segment AB go with? It goes with segment DE. So it is 4 to 12. Now, that needs to be the same thing as the ratio of another pair of corresponding sides. For example, segment BC. It's probably natural to think that it goes with this one, and it does. But you should be using the statement, not what you think it goes with. Segment BC goes with segment EF. So this x minus 1 must go with 18, and it's got to be the same ratio as this. So we're going to cross multiply. Before we do, I might just make things a little bit easier on myself by reducing. Now I know that 3 goes into 18 6 times. So 3 times 6 is 18. 1 times 6 gives me that. 1 times 6 is 6, so I know that 6 equals x minus 1. Okay, so if I add 1 to both sides, x is 7. We're going to do the same thing Oh, actually, no, we don't need to do the same thing. We don't need to, we could find these lengths if we wanted to at this point. If x is 7, then we know 7 minus 1 is 6. If x is 7, 7 plus 1 is 8. 3 times 8 is 24. So we know these lengths, and we can check this. 4 to 12, is that 1/3? Yes. 6 to 18, is that 1/3? Yes. 8 to 24, is that 1/3? Yes. You only needed to find x. So x was in 2 different places there, so we know that's right. We just checked our work. Which of these triangles are similar? Write a similarity statement. So let's compare these two triangles. Just like we did on that last, or one of the previous slides, I'm going to put these sides in order. 20, 24, 26. If these two triangles are going to be similar, their sides are going to correspond in that ascending order as well. So we'll call it 24, 30, 33. And we're going to reduce these ratios. I know that 4 goes into both of those. So it would be 5, 6. I know that 6 goes into both of these. It's going to be 4/5. I can stop right there. Those are not similar. Maybe this one's similar to this one. Check your ratios. I'm going to put my sides in order. 24, 30, 33. Put these sides in order. 30, 36, 39. Four goes into both. No, 4 doesn't go into both. 6 goes into both. So that's 4/5. I know that 6 goes into both here. Those are not the same. Those are not similar either. Maybe the first one and the third one are similar. So we're going to check one more. I'm going to squeeze it down here. 20, 24, 26, 30, 36, 39. This is looking better. This is going to be 2/3. 12 goes into both here, so this would be 2/3. And 13 goes into both there, so that would be 2/3 as well. Okay, so these ones are equal. So your first one and your third one are similar. They ask you to write a similarity statement, so we'll do that. Kind of out of room, so I'll do it up here. I'm going to say the triangle LMN is similar to triangle. Got to watch the order now. L is in between the smallest and the largest side. So I got to find that same guy over here between the smallest and the largest. It goes with Y. M is in between your two smallest. Here's your two smallest here, so that goes with Z. So your last letter would be X. Okay, last one here. The shortest side of a triangle similar to triangle RST is 10 units long. Find the other side lengths of the triangle. Okay, well, if the shortest side is 10, the shortest side here is 24. So I know my scale factor is 24 to 10, which is, we reduce 12/5. Okay, now I'm going to use that 12/5 because if that's my scale factor, then we can use that to find the ratios of all the sides, and we can find any side that's missing. So the second biggest side is 30, and this is coming from the bigger triangle, the 30, because obviously 10 is smaller than 24. So we can call that X, perhaps. Use that same scale factor, 12/5. Solve for what corresponds with 33. Now, when you cross multiply here, we're going to do 5 times 30. That'll give us 150. And then we're going to divide by 12. and that gives us 12.5. So we know the median side length on this other triangle that's similar to triangle RST is 12.5 units long. Here we're going to multiply 5 times 33, and then we're going to divide by 12. We're going to get 13.75.